Now let's go into another topic, fundamental matrix transformations or decompositions. First, I will introduce the idea of similarity transforms, and then introduce something like orthogonal matrices. And then I'll present the triangular decomposition, also called LU decomposition and Chomsky decomposition. And also I will introduce something like Jordan transformation and singular value decomposition, some ideas, and how to perform this kind of decomposition or transformations. So let's start the first topic, the similarity transforms. For a given matrix A, if there exists a matrix B, which is a full rank, which is a square non-singular matrix, then we can transform the original matrix A into another form, X. And this kind of transformation is called the similarity transform, because the eigenvalues of X is exactly the same as that of A. And the shape of the two matrices may be different. So this kind of transformation is called similarity transformation, and B is called the similarity transformation matrix. And why we need such a transformation? I can give you an example first. If you have a matrix like this, there is no specialty in the matrix terms. Sometimes you may not readily see the property of the matrix. And by the introduction of similarity transforms, you may transform it into a diagonal matrix sometimes. If you can properly choose the transformation matrix, you can transform it into a diagonal matrix. And the way of doing it is to use the eigenvalue matrix sometimes, but sometimes this may fail. I will explain it to you. If you use eigenvalue matrix here, you can convert a ordinary matrix into a diagonal matrix if there is no repeated roots, eigenvalues. And also, sometimes if you can properly choose the T matrix, you can transform the original matrix into a companion form like this, so that the properties of the matrix can be observed. So you can convert a matrix in this way. And I will explain later how can we select the transformation matrix. And here you just have to know that if you can choose the matrix V or matrix T, you can convert the matrix into another form. And also there are also very important, there is another important kind of matrix called orthogonal matrix Q. And the orthogonal matrix Q satisfies these equations. And the orthogonal matrix of A can be constructed by use this command. I have already explained how can we convert an ordinary matrix into a diagonal matrix. That is, we have to use the eigenvalue matrix, eigenvector matrix, to convert it into a diagonal matrix. And here is the example. We have B, the diagonal matrix, and we have A, the eigenvector matrix. So what we need to do is to find, is to use a command like this. in the function call previously, we find that V is an eigenvector matrix. And if we take eigenvector matrix as the transformation matrix, and if we use this command, then we can get a diagonal matrix containing all the eigenvalues of the original matrix, like this. So in this case, we can convert an ordinary matrix into a diagonal matrix if we use eigenvalue matrix like this. And there are something I have to say that if you want to get a diagonal matrix, then V must be invertible. If it is invertible, which means that all the eigenvalues must be distinct. They could not be the same. There shouldn't be any repeated eigenvalues in the matrix. Otherwise, we cannot convert it into a diagonal matrix. And now I have another kind of transformation. How can we convert an ordinary matrix into a companion form matrix? So how can we find such a matrix? How can we select the transformation matrix? What can we do is something like this. First, we can construct a column vector X, and then we can form the matrix T in this way. And if T is a non-singular matrix, then we can use it to convert original matrix A into a companion form. And it should be noted that T is not unique because we can select X arbitrarily as long as the T matrix is non-singular. So we can try to find whether we can convert such a matrix into a companion form. And we can enter this matrix first. So now let's consider how can we select a T matrix. To generate a T matrix, we can give this kind of command. I will explain it to you. First, we can generate a column vector, and the numbers in the vector could be 0 and 1. If we use floor, there we can extract the integers. And this one is generating random numbers in this interval. So we multiply it by 2 and then take the integer. So the numbers in X can only be 0 and 1. And we can try to find generate randomly such an X vector. And then we can construct a T matrix. And then we can check whether the rank of T is 4 or not. If it is 4, then we say that we can find one transformation matrix, T. If it is not 4, we can go back to this file and generate another X. And then we can construct another T until it is 4 rounds. Then we can construct a transformation matrix T. And we can use similarity transformation and get a one matrix.